why I received the Nobel Prize. And the Nobel Prize we received for a thing called catalysis. And if you're wondering what catalysis is, there's a really easy way to learn about catalysis. So if you look around you right now, absolutely everywhere, or if you look at this photograph of my office in Princeton, everything is made from a chemical reaction. Absolutely everything from a chemical reaction. So if I pick just one thing, so down here is my coffee cup, this is my coffee cup, and if I go to this chemical reaction, this is the chemical reaction to make caffeine, the key stimulant in coffee. And almost all chemical reactions need energy. They're not spontaneous. And so because of that, you can show this as what we call an energy diagram. And I apologize, this is not going to be technical, but this is just an easy way of showing an energy diagram. And an easy way to think about it is imagine every night when you walk home, you have to climb over a big hill. That would require a certain amount of energy every day to get home. What catalysis does is catalysis builds a tunnel that goes through the hill. And it makes it so much easier for you to get home, but catalysis makes it easier for chemical reactions to happen. So in many ways, catalysis makes existing reactions easier, faster, and in many cases allows chemical reactions to happen that were previously impossible. That's what a catalyst does. Okay, so in terms of the type of catalysis that we actually performed, I thought I'd show you just a couple of different things along the way, just to prove to you why what we did and why hopefully you'll find it interesting. But in 1996, which was a long time ago, but in 1996 there was two ways of doing catalysis. There was biocatalysis, which is using the enzymes in your body to actually do this type of making chemical reactions faster. Or there was metal catalysis, which is based on design. It's based on humans who have designed ways of actually thinking about doing this. What we became interested in was the idea, could we stop doing metal catalysis? Because metal catalysis is not sustainable. Sometimes it's bad for the earth, it's bad for society. And if we look at a typical metal catalyst, which is the one shown here, you can sort of see on the right-hand side, we have this thing called an M for a metal. And many metals can be expensive, they can be toxic, they can be difficult to work with. What we started to realize was the other side of the same